Hi everyone, this is Teacher Vench. Today we will learn a concept about electricity, which is Ohm's Law.
So for today, the essential questions that I wanted you to answer at the end of our session would include number one, what is resistance? Number two, what is Ohm's law and how can you solve for each of the variable involved? And then number three, what is the relationship of current, voltage, and resistance? So meaning the three main vocabulary that we will go over with for today is current, voltage, and resistance. And then of course, when you combine three of them, we can be able to have Ohm's law. Okay, so let's go ahead and start first with voltage. So again, when you combine these three, that is where Ohm's law exists. So to understand it better, we need to, learn them one by one. So we'll start with voltage. So when we say voltage, that is the charge or electron pusher. So if you have seen our simulation earlier, when we turn on the switch, the battery causes the electrons to flow. It pushes the electrons to move. So meaning voltage causes current to flow or move. Without it, your current or your electrons will not be flowing. And if the electrons are not flowing, then your appliances at home or devices at home will not work. So voltage sources includes your battery, of course, and then generator for bigger stuff, and then of course outlets at home. So you're using that as a power source or an electron pusher. Voltage has a symbol big letter V. Since this is a quantity, meaning we can be able to solve for it. That's why there's a device who can check how high the voltage is. And of course, checking the voltage is very important also for safety. Unit is volts with the same symbol. So it's still big letter V. So now that we have the voltage, which is the first component in a circuit, in order for it to work, voltage is connected to your copper wire. And in that copper wire, actually, that is where current will flow. So let's talk about current. So current is a flow of charge of electrons. So now that you connected the wire to the battery that has voltage, it will now push the electrons in order for it to flow. So your flow of charge is what we call current within a conductor, or how fast charge is moving. So take note, conductors are materials that allows current to flow, for example, metals and copper wire. So the symbol for current is big letter I. The unit for current is amps or ampere. It was named after the scientist Andre Marie Ampere. So current is very important part in order for the electricity to be present. Okay, and the last thing is, if you have the battery, now you have the current, well, the electrons will be flowing. The next thing is the resistance. So from the term resistance, we can say that there's, an oppose, meaning it opposes something. So resistance actually opposes the push from the voltage source. This is an example of a resistance. Usually you would see this inside appliances. So the device that you have at home, when you connect it to a wire, there is actually a resistance. Resistance also affects the speed of the current. So without the resistance class, there might be a problem, okay? Because resistance is the one who controls the flow of current. So from the example that we have earlier from the battery, current will flow, electrons will flow in the wire, and then the bulb will actually use some of it. So that's why the bulb will light up, and then it will go back again, continuously flow, because your circuit is a closed loop. Okay, so your resistance has a symbol big letter R, and the unit of this is a Greek alphabet omega. The symbol is Greek alphabet omega. It is known as ohms. It was named after a scientist who studied resistance. Let us now talk about the relationship of voltage to current and then current to resistance. Okay, so first is voltage and current. So if the relationship says that if the voltage in a circuit increases, the current will also increase. So meaning same thing happened. If the voltage is higher, your current will also be higher. If the voltage in a circuit decreases, the current will also decrease. We call that in science or in physics, direct proportional relationship. So when we say direct proportional relationship, when one is higher, let's say when voltage is higher, current will also be higher. Okay, let's take a look at the simulation and let's see if this statement is correct. Okay, so we have here our voltmeter, the one who measures voltage, and then current, the one who measures, or ammeter, the one who measures current. So as you can see here, our voltage is 9 volts and then our current is 0.9 amperes. Now, what do you think will happen based on the relationship? If voltage goes higher, current will also go higher. So let's see if that is really happening. Okay, so let's say we will add one more battery to increase the voltage. And then let's take a look at what will happen. Okay, so as you can see, our voltage changes from 9 to 18, meaning there is an increase, it doubles. And your current also from 0.9, it changes to 1.80. That means to say they are really direct proportional. When voltage doubles, your current will also doubles. Okay, how about the relationship of resistance and current? So if the resistance in a circuit increases, the current will decrease. So meaning their relationship is opposite to each other. So if the resistance in a circuit decreases, the current will increase. So resistance increase, current will decrease. Or the other way around. If current increase, resistance will decrease. In physics, we call that as inversely proportional. So let's take a look at our example, okay, to show proof that indeed this relationship is correct. We have your our voltage, we have your our current, and your bulb and switch has your resistance, which is 10 ohms. So 18 volts, 1.8 current is equivalent to 10 ohms resistance. How about we will add one more battery? So of course, adding one more battery would increase the voltage. From 18 volts, it now changes to 27. From 1.8 amperes, it now changes to 2.70. However, when you take a look at the resistance, your bulb, it still stays the same. Therefore, it is really lower because your voltage and current is now triples, but your current is still 10 ohms. Meaning, the higher the voltage, the higher the current, your resistors will always stay the same. They will be lower. Okay, that's why they are inverse proportional. Okay, so I hope it is clear. Direct proportional for voltage and current, and then inverse proportional for resistance and current. The combination now, or the relationship now between those three, current, resistance, and voltage, is what we call as Ohm's Law. So Ohm's Law state the relationship between current, voltage, and resistance. So it states that the strength of a direct current is directly proportional to the potential difference or voltage and inversely proportional to the resistance of the circuit. So German physicist George Ohm had a law named after him because of his extensive research. So the name of the physicist is George Simon Ohm. Now from this statement or from this law, we can now come up with an equation. Okay, because remember I told you earlier that current, voltage, and resistance, these are quantities or factors that affects electricity. So it is very important for us to know how to solve or measure the voltage, the flow of current, and also the resistance. Let's go ahead and take a look at its equation. So from the statement, which says current is directly proportional to voltage and inversely proportional to resistance, we can now come up with an equation. So voltage is equal to the current multiplied by the resistance. So just for you to remember, voltage again is measured in volts, current is measured in amperes, and resistance is measured in ohms. Now, there are instances wherein the one missing is not voltage. Sometimes the missing quantity is current or resistance. So in order for us to solve for it, we need to rearrange the equation. And since we have three quantities involved, the simplest way to do that is by drawing a triangle. Then we divide the triangle into three, and then write the informations inside the triangle. Your V will be on top, and then I and R at the bottom. Okay, now, if V is missing, what you will do is you will cover V, you will cover it, and then copy the remaining quantity. So V equals IR, because they are beside each other, meaning you will do multiplication. However, if I is missing, you're gonna cover I, and of course you will copy the remaining quantity or variable, which is V over R. So to do that, all you have to do is to write down I, or current, equals voltage divided by resistance. And then if resistance is missing, cover the R. So R equals, and then copy the remaining variables, V, line in the middle, over I. So these are the three equations that we will be using. So now that you know the formulas, we can now be able to solve for different problems related to Ohm's law. Okay, to start, I will provide an example on how to solve for Ohm's law equation. Again, in solving for Ohm's law, it could be that the missing one is voltage. Sometimes the missing is current, or sometimes it's resistance. So we have an example here. A 50 volts battery maintains current through a 20 ohms resistor. So let's say this is your battery. And then there's a current, and then you have your resistors here. Okay, so your battery has 50 volts and your resistors has 20 ohms. The question is, what is the current through the resistor? So what is the current flowing here? So same with other problem solving that we're doing in the past, we need to follow the GRRSS format. Okay, so I would write first the given. So the given is voltage equals 50 volts and resistance equals 20 ohms. I would identify the required. So it's in the question, obviously, what is the current? So I is required or missing. Then I'm going to rewrite the formula. So the formula for I is equal to V divided by R. And then I'm going to substitute and solve. So V is 50 divided by your R, which is 20. 50 divided by 20 is equivalent to 2.50. And then you will need to write the unit for current, which is amperes. So 2.50 amperes is the final answer, or 2.50 amperes is the current that is flowing through the resistors. How about on the next example? I have here an example of a circuit. It has a battery, and then there's an ammeter to check the flow of current, and then we have the resistors as well. Your 3 ohms is your R. Your current is 2 amperes. This is your given numbers. Okay, we need to solve for the voltage. We know that the current flow is 2 amperes, and then the resistance is controlling the current flow using 3 ohms. We need to find out now the voltage. So what formula are you going to use? Write it down here. There's a triangle, V is covered. So what formula are you going to use? Okay, very good. So you have V equals I times R, or current times resistance. All right, so you will substitute and solve now. Okay, very good. All right, 3 times 2 equals 6. What is the unit of voltage? Unit for voltage is volts. So the final answer is 6 volts. So to summarize, resistance is the property that determines the amount of current flow through a particular material. So V equals I times R is also known as Ohm's law, if you wanted an equation form. Ohm's law states that the strength of a direct current is directly proportional to the potential difference, which is your voltage, and inversely proportional to the resistance of the circuit. The unit for resistance is ohm, and it has the abbreviation omega, or the horseshoe symbol.
Thank you so much for watching. Hope you learned something today. Bye.